Okay, now let's have a quick read. A random variable x has probability distribution defined as follows, where k is a constant. Show that that is the case. Now, the way I do this, and then it goes show that the table values of x as the probabilities. I tend to do this in one go, really. I tend to say, well, this is x, and I start saying what are the values of x. So x can be 1, 2, 3, 4, or 5. And then I say what is the probability of achieving x. Now remember that anywhere else x is 0. X is 0, otherwise x is 0 for when it's 0, x is 0 for 6, 7, 8, so it just cuts it all down the graph. And then you just put this value into this formula, what they say. So 1 times k is k, 2 times k is 2k, 3 times k, 3k, and 4k and 5k. Okay, so it's cut it down, really. Literally, it's a straight line graph, and it's told you that all that area, what we know for probability, all this area underneath this graph is going to equal to 1. So literally, it looks something like this. It goes from 1, and it's told you this is the area, and all that area is going to equal to, under that is going to be 1, and our probability is going to consist of that distribution. So what we do here now, we do k plus 2k plus 3k plus the 4k and the 5k. We know that's going to equal 1. So I've got number bonds 5, 10, 15. I've got 15k is equal to 1. Therefore k must equal to 1/15. Okay, so if I now want to show that the probability when x is equal to 3, I can do, I'm just going to do it here quickly. So probability x is equal to 3. Well, we know when x is equal to 3, the probability is going to be 3k. And we now know that k is a 15, so that's going to be 3 times a 15th, which is 3/15. If you simplify that, it's 1/5. Decimalize that is 0.2 as required. Happy days. Now that's done, and show in the table values of x and their probabilities. And what I do is I just stretch that out. Probably could draw another table. I'm not going to, but you should just make sure that there's no arguments, but I'm sure it'd be okay. But I'm going to leave this in terms of 15ths. Okay, I'm not going to decimalize it. You can do. It's just easier for me to say that's 1/15. That's 2/15, 3/15, 4/15, and that's going to be 5/15. Okay, if you want to decimalize it, it's up to you. That's all good. So we're happy with that. So really, 5 marks. I think pretty straightforward. I'm quite happy with that. Now, then they always tend to put one of these questions in. Okay, 2 independent. Now, what does that really mean? It means they don't affect each other. They're not affected by each other. And the reason that's important, it means that you can just multiply those probabilities together without any consequences. They're independent. Okay, one does not affect the other. That's the beauty about it. They have to state something like that. That values of x are chosen, and their total is found to be 7. Now, when you look at this, now you probably might think there's loads of combinations of getting 7. The total of, so 2 of those are chosen, and the total is going to be 7. So let's see how I can make 7. Let's just check the combinations. You could get a 2 and a 5. Okay, and you got 2 ways of getting that, because you could get a 5 and a 2. Okay, so you got, I'm going to put that times by 2. You want to work at that. How else could I make 5? I could get a 3 and a 4. Oh, sorry, not 5. I keep on saying 5. The total is going to be 7. 2 plus 5 is 7. And how else could I make 7? Is 3 plus 4. Or you could get 4 plus 3. So you got 2 ways of that happening. 4 plus 4, no. 5 plus 4, that's it. Those are the only ways we could get 7. Okay, so then you work out these probabilities and double it, and hopefully we get the probability of that. So I'm going to put CI here, and I'm going to say the probability of getting a 2 and a 5. Now the probability of getting a 2 is, look from here down here, it's going to be 2/15 multiplied by, like I said, the independent, so you can multiply. Probability of getting a 5 is 5/15. If you just do that now, before I did that in my calculator, I know I'm going to get 2 of those, because I can do it the other way around too. So I'm going to multiply that by 2, okay, because there's 2 combinations, and that will give me 20 over 225. That's my first one done. Or you could have that. Now, or means the probability you must add. Now you should know this. And means you times these probabilities, so we multiply them. Or means we add the probabilities. This is or. You could have probability of getting a 3 and a 4. And don't forget, we've got 2 combinations. Now the probability of getting a 3 is 3/15. And means to times the probability of getting 4 is 4/15. And if we multiply that by 2, because we've got 2 combinations, we've stated that here, we'll get 24 over 225. Now because we said or, we can, to get the probability that the total is equal to 7, we just simply add these together, because you could have that combination, or, which means add that combination, which gives me 44 over 225. Now again, you could go into your calculator and put it in a decimalized value, which I'll quickly do. I don't know if I've got it written down somewhere here. I haven't, so I'll quickly do it. 44 over 225. Yeah, it's a recurring number, so I'm just going to write it as to 3 single figures. That will be 0.196. Any questions on that? We're good? Okay. So 3 marks, happy days. And this is like a standard style question with a combination. Part 3. Now, given, when you have something said given, or something happens given that is the case, you should use this. Now you should have this in your formula booklet. When you got probability of A given B, that formula is probability of getting A and B. And because B is given, the probability is now out of B, okay? Because that's been given. That's the formula. Make sure you use that one. So I'm going to say, when it says here, probability, given that the total is T, determine that one of the values is 2. Now this is, I mean, I don't know why they give you 4 marks for it, but it's nice. Thank you. We love it. So this is probability that one of the values is 1 value equals 2, given total is 7. Now that is the probability that, what is the probability of getting 1 value equals 2 and the total is 7, divided by probability total equals 7. Well, we've just worked out what the total of getting 7 is, that which is 0. No, it isn't. 0.196. And we also worked out the probability of getting at least getting one value of 7 is that there's no 2's in getting 7 with a 2 is that there's no 2's in here, so you just put 20 over 225. Now this is why I should have left it as a fraction. I'm going to change that because I know that was 44 over 225. So I could cancel these out, and that will be just 20 over 44. Okay, and that's just 1/5. So you could leave it as a fraction, and then or you can change it as a decimal. And that's it. Happy days. 5's into there. 1 minute. Have I done this right? And divide that. What have I done here? That was 20 over there. Half that is 10 over 12. No, wait there. I've done something silly here. Just give me 1 second.
Why do you not times it by 44 over 25 at the top value? Then it just comes up.
Yeah. So I've just times top and bottom. I've just done something silly here. So I've just times that by 225 and that by 225. Yeah. So I get 20 over that, and if I half the top will be 10 over 22. Half it again. No, it was right. 5 over 11. I'm just having a mad moment. That is correct. Okay.